To the final talk or final lecture slot for today. My today's topic is microservices, and I want to share what experiences we made the last 1.5 years in cloud native development, and especially microservice architectures, while implementing a software as a service on SAP Cloud Platform. My name is Helmut Konigseder. I'm a member of MSG Systems, Technical Guidance Department. I have about 10 years of product development experience, mostly in SAP environments. And since 1.5 years, approximately, I'm in developing the reinsurance solution IRE. I had the stand at the launch up there, where we develop a software as a service for the reinsurance market. Disclaimer, there is cloud native and microservices. It's somehow interconnected, the two topics. It's not going to distinct too much. At some points will really be specific for microservices. Some points will be more part of the cloud native stuff. But I think it goes along hand in hand most of the time. What's on the agenda? I'll first try to define microservice architectures, give some insights on the major characteristics and advantages. I picked out 3 of my liking for that each. I'll then go in the main part, talking about what's important from my perspective, mainly from the organizational point of view, not too much technical details here. And finally, I want to give my opinion on the question whether it's better to start with a microservice architecture or a monolithic approach. And it's all based on coming from the Netweaver Stack. This is my background. I hope a lot of you also have a Netweaver background. You'll benefit most. The guys developing software as a service stuff already probably won't have too much contact to Netweaver in the past. So where do we come from? We have a Netweaver Stack, and we know the applications, these octagons, they live happily in the Netweaver Stack, and they share a database where also applications can live. And when we develop those applications, we typically adhere to the rules given up by the Netweaver. We use the modules provided. We know that we can integrate our applications via the database, and so on. And everything runs on one instance using one shared database. And this is where microservices fundamentally differ, because microservices, these are 6 boxes with octagons standing for application. They are basically 6 parts in this example forming one application, while on the Netweaver side, looking at a monolithic approach, we have several applications living next to each other. And a microservice architecture, as you can see here, typically has databases per microservice. It's just as an example for resources. That's why we would go for microservices, so that applications can have their own separate resources and they can follow their own rules, basically, as long as they fulfill in the end the goal they want to fulfill. And this is why I basically like to think of the Netweaver Stack as a kind of a kingdom where we have King Netweaver giving us the rules we follow, and microservices basically being more the thing where we have a federal republic, where we know that each microservice can make up its own rules, like it's in the countries that are federal republics, but still everyone has to follow the rule of the country, or has to achieve what the application has to achieve. And that brings me to, in my opinion, the 3 most prominent characteristics that a microservice architecture has. It's the dedicated resources. These applications over there, they don't integrate over the database. It's technically not possible. Okay, it could be made possible, but that would not be the point. In our Netweaver applications, or in our classical ABAP applications, we know that we can, if we use, for example, SAP Business Partner functionality, we can just, if you so desire, access the database tables for SAP Business Partners and read it. I know Markus' talk in the morning had decouple. This is probably not a very good idea to formulate hard-coded SQL statements against a database table that's not your own property. So this is one of the points where microservice architectures differ. They have their own databases. So you are not able to integrate via them. You have instead to favor the integration over hopefully well-designed or well-formed interfaces. Now, you could integrate in different manners over interfaces. The most prominent one is to use REST APIs in microservice fields, but there are others, like message brokers, for example. And those message brokers now give you one very specific possibility. You can favor asynchronicity, or they enable you to do that more easily. And why is that a major characteristic of a microservice architecture? Well, I think if you have the 6 boxes over there and you know these 6 boxes form one big application, then at some point a user interaction will have to have more contact than with just one microservice. Think of your Fiori Launchpad. If you're in the SAP ecosystem, you have your Fiori tiles. You open one as a user and you do something. And at some point, you need some data from another microservice because, I don't know, you manage your reinsurance and then you need some current accounting stuff. So what would you do in the classical world? You would just call the function module or read from the database. There, you can use the interfaces for selecting the data. And if you do all this selection, all this integration with synchronous calls like REST APIs, then your network time, for example, sums up for every communication that you make. So if the upper left microservice communicates with that one for fulfilling one user request, and that one communicates with that microservice to fulfill a user request, and it's all synchronously, then we know the path of communication will make our user interaction slower. And if there is any failure or any problem with the network, then this problem will backfire to the user directly. So to avoid that, we build microservices basically with asynchronicity in mind, meaning that instead of direct integration, we try to fulfill a user request with the data we have in one microservice. It's basically an own application. And then we say to the user, okay, you're good to go. And in the background, we automatically process the data. And as soon as the user needs to step in again, he's somehow informed, for example, via the Fiori Launchpad again. And this is, from my point of view, a very important thing to keep in mind when going for microservice architecture, that you have to design it to take advantage of asynchronicity. Otherwise, you are going to have problems later on. If you just say, okay, I slice up my application to nice 6 separate applications, they have databases for their own, and then I just act like they are living on the same machine and are integratable as it was in the past. Okay, so for the characteristics. Now, what advantages arise of that? Well, by having those boxes, we can now quite easily say, okay, I need more load on that application, need to develop it faster, so I split it up. And since microservices are own applications with their own dedicated resources, it's easier than it was in the past because you have not so much interconnection in those teams and those code blocks. And there is now the possibility to specialize teams on certain technologies, like, for example, the Fellowship of the Code can now concentrate on the PostgreSQL, while only the dudes have to take a look at HANA. This is the thing that's typically told as an advantage of microservice architectures. I would add one restriction: you still need governance. If you allow teams to develop microservices totally independent, then you probably have the problem arising that no one knows what the other team is doing. So you need to give out some kind of guidance how you should basically develop your applications. The second advantage that I find that I like a lot is the continuous and separate evolution aspect, because if I split up my application to several parts, those can evolve separately. I have here the box with 54.4, just an arbitrary value. That means there's a lot of change to this microservice. While we have another one that has version 1.0. It's never been changed at all. And we all have those parts in our monoliths as well. We have the parts that change a lot because there is a lot of, perhaps it's the core domain of our application, or it's something that we get a lot of bugs and change requests. And we have other parts that we develop and they run just forever because it's easy, or it's just a functionality that it's barely touched. And in a monolith, I typically have the problem, since I integrate over the database, that everything is interconnected very much. And when I change one part here in a monolithic environment, I probably have to test that application part as well, because basically I don't know if my database change broke something in the other application. Separating those stuff mitigates that need for testing and therefore allows for a more free, separate evolution of software, in theory at least. Of course, what's still a problem is if we integrate over interfaces. Now, if I change my interfaces, I might still break the overall system. So there's a need to mitigate that risk as well. And the final advantage that is contained in almost every article about it is that microservices are per se scalable. That means simply by implementing a microservice architecture, you scale your application by the paradigm of splitting different things. I have my application, and it consists of 6 parts, for example, in this thing here. And now, because I made 6 applications out of one big application, I have, if I run it on different resources, 6 times the application or computational power behind it. This would be the theory. And of course, by making smaller application parts, it's more efficient to scale up or give more hardware, more consumption or more computation power to a single application part, as it was in a monolith, where when I scale up vertically, I give power to the whole system, and the whole system shares that power. It's the same with horizontal scaling. So much for that. So these are the 3 characteristics and advantages that typically come together with microservice architectures. And I already mentioned some of these advantages are at the same time disadvantages, like I need to take care now of stable interfaces, or I need to give out governance to application teams, application development teams, and so on. So the question is, what's important when we start with a microservice project? And once again, coming from NetWeaver, we are used to some things. When I've had 8 years of developing mostly ABAP on the Netweaver stack behind me, I was used to developing my source code with SE80 or ADT, the ABAP development tools in Eclipse. But still, the code would live in the Netweaver stack, and I would never have to take care about my application source code. It's just there, it lives there. And there is the checkman that runs nightly, that checks my code, that reports how the quality of my code is, and I have the ABAP test cockpit in the newer versions, where I can statically analyze my code. And for transporting it in my landscape and giving it to customers, I have the handy SE09. It's all integrated. It's one homogeneous, big, very powerful stack that takes care of everything. Now, in a microservice environment or non-ABAP, non-NetWeaver environment, I have to take care of these things. And I suggest when you start, you set up a project infrastructure. This might be obvious to the guys not implementing or not living in that space, but my experience is that it's not as obvious when you worked a lot of, or when you're very focused, very experienced with the Netweaver stack. So you have to create a source code repository like Git. You have to install something like a Jenkins when you have been to Otmar's talk about continuous integration. That's the part where Jenkins comes into place. You have to give your developers tools, okay, IntelliJ, Eclipse, whatever, and you have to install an artifact repository as a minimum requirement from my point of view, how to start with a project infrastructure. And then again, you have one additional complexity. You have now separated development and runtime. You develop this stuff locally, no longer in the Netweaver stack, and in order for it to run, for customers to be visible, you have to deploy it somewhere. And this is, from my experience, the first step that helps your ABAP developers on the journey to cloud native, actually, because otherwise, my experience is they're kind of lost in the wild. Just develop, or I as well, just were used to the NetWeaver taking care of all that. And one additional aspect that's coming with that, or the project infrastructure, is that you should probably establish a continuous everything approach. You should at least establish a continuous integration that continuously evaluates your source code if it's buildable, if it's compilable, and if the automated tests run. So you have to write automated tests, but that's another story. Won't talk too much about that. And you have to keep in mind that in the non-NetWeaver environment, you don't transport code, you transport artifacts. And you need for that, in order to be a good thing, artifact repositories like the Nexus, for example. Not going too much into detail here. If you're standing before the challenge of now having experience in the NetWeaver environment and you go to the SAP Cloud Platform, for example, by building a side-by-side extension, then I suggest take a look at the S/4HANA Cloud SDK. Marco mentioned it already. It gives you basically exactly that part, the continuous integration server and a good set of tutorials that help you to manage the first steps in that direction. After you've a project infrastructure and you establish continuous everything, or basically next to it, or at the same time, you should rethink about the way you design your software. And this picture basically depicts a set of gear wheels that form one application. And this application happily lives in one database, and so somehow everything is connected. This is a view that we typically have, and when we think about our software, then it's hard to take out pieces of that software because we think of it as one big part. Now, if we want to split up that thing in different applications, it's of course not a very good thing that it's also interconnected. So you have to do something against that. And I suggest that you start with domain-driven design. This is nothing done very easily. If you don't have a colleague that's familiar with that near you, you probably have to read a lot to understand the principle behind it. But at some point, you will probably find out that with this kind of tool for designing software or for depicting how things look, for making our plans, you will recognize that it's a very convenient or very good way to design a piece of software, especially if it's more complex. And then you hopefully find out what bounded contexts you have in your software. For example, in the typical web shop application, you separate the shopping cart from the catalog or whatever you do. And based on that pieces that you flesh out together with the business people, you can then build the microservices based on this so-called bounded context, so that you have the recommendation microservice that allows you to give the users of your software recommendations. Thinking about that, now we have the infrastructure, we have understood continuous integration at least, or have continuous deployment in place from theory, and we know what microservices we want to build. Now we should start thinking about how our data is going to be consistent, because what we're used to in our databases is that we have something like ACID. That means we have a database, we have transactions, and we know that either everything goes well and it's committed and persisted, or all of it together is rolled back. In the distributed system, you don't have ACID because you have different databases. Even if you're operating on the physical piece of hardware, you shouldn't rely on ACID to work, because at some point you might want to split up microservices between resources, and then you're again lost. So you have to think about your consistency model when starting. And in the best case, this means that we have no dependencies in form of consistency between the microservices. But I guess this won't be very realistic in the most cases, because probably at some point I have some kind of interaction between my microservices. Otherwise, these would be totally disconnected applications that are simply applications. And we have to come up with a way to make the data consistent. One thing is that you say, okay, or our application will become consistent over time. I've already talked about asynchronicity, and that means that somehow in the background, things are computed. And the eventual consistency approach would be to say, okay, after the processing is done, at some point in time, the data of the system will be completely consistent again. And I have measures in place to ensure that, for example, by compensating failures. So this microservice doesn't respond correctly to a request from that microservice. So this microservice has to react on that failure there and, for example, retry the interaction or roll back its own database to make the whole system consistent again at some point in time. No longer live or real time as it was in the asset field. Another thing you have to take in mind about data consistency is that suddenly you have to think about, for example, data correlation. We have in the classical applications, it's very clear who did what because they were typically built synchronous. When I think of FSRI as an MSG product, where the user interacts and creates stuff with UIs that contain a lot of data, then it's clear at every moment who created that data when, because it's simply saved when he clicks on the save button. And there's perhaps a batch process in the background that does something in the background, but still it's clear that the batch process created that data that he saves. Now here, when we go for high asynchronicity, the question is, how do we know what user interaction in this microservice did 3 iterations later via several domain events and asynchronous calls happening, create data in that microservice? How does that correlate to each other? And you probably have to come up with solutions like correlation UUIDs or whatever you can think of just to make that happen, to make the correlation of your data visible, for example, for legal reasons or because simply your customers might ask who created that posting or who created that data in that microservice or in that database table. And you need to be able to answer those questions. The last thing it should is when you go for cloud native or when you develop a microservice architecture, you have a lot of new challenges. In a typical environment, or at least as far as I experienced it over the last 10 years, is that we mostly think of silos. We have, for example, very prominent a test silo that tests the software before it's released to customers. And we have product owners and we have tech support and operations that somehow are living in their own workspaces and they're specialized, and it's typically not very easy to get together with all the people working on a project because it's simply not so clear. And this is one thing where I suggest that you proactively join forces and try to form, instead of a dev team and an ops team and a test team, the dev, security, test, architecture, product owner, project lead, ops team in the best case. And why? Well, we're not talking about a matter of programming languages. When going from NetWeaver to the cloud or to implementing a microservice architecture, it's not sufficient to give out some lectures on Java and say, okay, now go ahead. It's more of, simply more topics coming along the way. Then everyone needs to understand these challenges because the test team that does the manual regression tests for your big piece of software probably won't be very happy when you tell them, oh, by the way, everything is automated now, and I think we don't need you any longer. That won't be true, but you have to get the knowledge of the guys into the software as soon as possible, so you should get in touch. This is just to have paradigm shift once in the slides. I think you have to team up with your colleagues to master that. Last, very concrete suggestion, just to have one that you can really go out and start with is, I think, when going for microservices, you have to start with reading. It won't, or it might also work that you just try it out, but there's a lot of work already done for you. For example, by Sam Newman, the book has mixed reviews, but I think it's actually a very good book about microservices because it touches a lot of topics on a very high level, at least. And you can then thereafter check what does my architecture lack so far, what do I have to look into. You can then try that out more specifically, or you can read along. And the other book is Domain-Driven Design Quickly. For starting with DDD, you need some guidance, and this book has just 100 pages, and it sums really up very well what Eric Evans writes in the in this book, Domain-Driven Design. So this is what's, from my point of view, important when thinking about moving to a microservice architecture, or what the first steps from an organizational perspective could or should be. Now the question, how do we go along? If I'm standing before the decision for a new project, sorry, what architecture do I deploy? Do I go for monolithic one or for microservice one? Then there are a lot of things to consider, from my opinion. Martin Fowler says, okay, you can measure the complexity of the thing you build. And you can say, if it's not very complex, then the productivity will be higher if you build it in a monolith. If it's becoming more complex over time, then the monolith decreases in productivity because it's simply a hard thing to maintain a monolith over time. This is one approach to see that. One that I experienced over the last years is that you can also look at the available capacity. How soon do you need to get to the market with your idea? Because if you're unexperienced in your field, then you will probably invest a lot of time in technical topics when you go for microservice architecture, because you need to figure out what's about the consistency, what about the domain-driven design, what about all the other stuff that comes along with a microservice architecture, the interfaces, the asynchronicity, and so on. And you invest less time in the business for implementing your business need, for bringing value to the customers. So I would also look at the topic from that perspective. How fast do you want to go to the market? And another thing to consider is that a microservice architecture from the start costs additional resources. When we think of SAP Cloud Platform, you have something like application memory to pay for every piece of software you host there. And if I host 2 or 3 or 4 applications instead of just one, it's 2 or 4 or 5th the time of costs. And if I'm not knowing if the product is going to be successful, I might want to save that up. So, my opinion, I think you should start with a structured monolith. If you build something for the cloud and you're thinking microservice or monolith first, then go for the monolith and act like your application could be split up at any given time. So design it like you would design a microservice architecture. Use DDD, try to figure out what your bounded contexts are, and perhaps even let your data reside in different database schemas so that it's really clear what part of the application uses what data. And think about, for example, the asynchronous part. If your application, if you don't find a way to somehow move things to the background, then you probably will have a problem with the microservices later. So design your software as you would design a microservice architecture, but simply build it in one deployable so that you can, when the load starts, when you are successful, rip it up and get it going as microservices, easier as it would be if you build no one builds an unstructured monolith for purpose, but we all know that the monoliths are not so easy to split out as they should or could be. With one restriction, if you're willing to sacrifice development speed in favor of technical training, go for microservices. But then you should also know the business domain very well. So keep calm. Not everything can be learned and achieved at once. Also, one important lesson, you have to keep track of what you have to do. Take baby steps. Start with reading and remember to give feedback on the IT conference. Thank you very much. What about questions? Any other questions? Roxy?
Could we apply some best practices from the microservices when we don't have any way in actually changing the monolith we are working on? So for example, if we are on a S4 ABAP system, it's really impossible to make it a microservice architecture enabled. Do we have some best practices which we can apply also on this kind of development stacks?
I think what's basically always a good idea is to start with domain-driven design. This not only applies to microservices, it's really a kind of fundamental thing how to see the planning of your software development. And if you build an add-on, for example, for the S4 stack, then you can also look at the piece of software you want to build from that domain-driven design perspective. And you can then split up your modules you build, your function modules, your applications in the Netweaver stack according to the domain-driven design. And although you cannot split up the resources as easy, you still can act like it's separate so that you can benefit, for example, from a more seamless evolution of your different modules. Because when you know that module A never touches the database of module B directly, you can change the database of module B with more confidence as you would be able to if you interact on the database level between your application parts.
I think exactly the extensibility that we discussed, the APIs that are available are some sort of provision of, in this case, not a microservice, perhaps it's rather a macroservice, if you will, if we speak about S4. But this is exactly the way. I mean, treat it as a microservice, use the APIs, and build whatever functionality you want to add to the S4. Right.
Any other questions, experiences? If not, Michael?
Yeah, one question. So how micro is a microservice? You mentioned several persistency services and also using HANA for sure. So HANA comes with a certain footprint. And I know from my customers struggling with some kind lack of flexibility here. So what's your experience in using HANA as a persistency layer for microservice?
Yeah. Actually, we decided against using HANA so far. We're evaluating it periodically, actually. We look at it, we look at what benefits would HANA bring to the project up to now, and what are the points where we would struggle more. For example, how would we integrate a HANA in our continuous deployment lifecycle? This is still, as far as I know, not solved really in a very good, also in a seamless way. So we evaluate it, weigh it off, and still go for Postgres. Although, of course, HANA would bring some cool features like an easier way to implement CQRS, for example, because we could use OData service generation capabilities of HANA. And with that, a lot of other features would be enabled, but still, because of it's very costly, it's very heavyweight, it doesn't scale too well, so still Postgres only.
MDC concept for sure, so there are some possibilities, and I think even some blog posts I've read about consideration how to design several HANA schemas attaching to microservices, but still I share your challenges.
Exactly. I think it's the question how this will go on, and I think for our application especially, we we deal with a lot of financial data. With a lot of data. So at some point, at least for one bounded context where we handle transactional postings that also integrate in the current accounting, we will probably implement a HANA there because those are the capabilities we need with the aggregation and the column-based stuff and so on. And we will probably in one or two microservices benefit very much from HANA. But we have to think if we think of the chart with the intersection at some point, we have to wait until our need is high enough and the struggle is low enough to implement HANA in our project. And how micro is a microservice, I think it's a very good question also, because there are some statements out there that say, a microservice doesn't have more than 800 lines of code. And these statements I absolutely don't agree. A microservice has nothing to do with the lines of code it takes. It's just, from my experience, it just means that the application is cut into several smaller applications. How big they are basically depends on how much effort I want to spend on integration and on my business desires. Because if I need transactionality or the ACID principle within one of the microservices, I'm going to have a hard time to split it up further, and I'm going to have a lot of pain if I split up too much. Yeah. So we have decided for rather big so-called self-contained systems because they bring the UI with them. in order to fulfill our requirements. And I think with that, I'll conclude my talk. Thank you very much.